Hi everyone. We're going to start Unit 7 off. We're talking about some basic properties of polynomials. And then we're going to go into adding and subtracting, which really just comes down to combining like terms, a skill we've already done. Alright, so first we're going to talk about how we can classify polynomials by the number of terms. If you remember, terms are parts of a polynomial that are separated by plus and minus signs. So a monomial, if you think about that prefix mono, a mono means one. Mono means one. Okay? So a monomial means that it is a polynomial with one term. So some examples would be 7, 7x, or ABC. So each of these are separate individual monomials. 7 is one monomial, 7x is a monomial, and ABC is a monomial. There's no addition or subtraction signs in it, so they are each individually one term. A binomial, so if we think about that prefix bi means two, so binomial means two terms. So some examples of binomials would be 3x plus 2 or a plus b. I could also have something with a subtraction sign in there. So 3x is a term, 2 is a term, they're separated by that plus sign, so there's two terms in that one expression, so we call it a binomial. Right? A trinomial. So I'm sure you've guessed that by now. A trinomial means something with three terms. Tri means three. So a trinomial is something with three terms. So some examples. So here we have a trinomial. We have 9m cubed minus 3x plus 72. So this expression here has three terms. So we consider this to be a trinomial. All right, and then finally we come down to polynomial. So anything beyond trinomial is just referred to as a trinomial. Poly just means many. So anything above a trinomial, we don't have a separate name for it. We just classify it as a polynomial. So it's anything with four or more terms. So an example of that could be something that looks like this. 9x is a term. That negative 17 is a term. The 2y is a term. And then the 3xy is a term. All right, let's look at some vocabulary. So the degree of a monomial, okay, is the sum of the exponents in that term. So we're going to be looking at exponents. Remember, sum means addition. So we'll take all the exponents that are found in a term and add them together. And that will give us the degree of that monomial. So an example is 3x to the fifth power, y to the second power. This is all one term. There's no addition or subtraction signs. So the exponents here on the variables are the 5 and the 2. So to figure out the term or the degree of this monomial, we're going to take those two exponents and we're going to add them together. So that 5 plus 2 is 7. So we would say that this is a 7th degree monomial. So it's a 7th degree monomial. All right, the degree of a binomial, trinomial, or polynomial is the highest degree of the terms. So in this example, I've got two terms. So when we want to look to see what is the highest degree of those terms, we're going to break it down. So this first term, well, we already looked at that. That was a degree of 7. So that first one has a degree of 7. The second one has a degree of 9. This one here. It's the only exponent in that term, so it's a degree of 9. The biggest one is 9, so we would say that that's a 9th degree binomial. Binomial because it has two terms. So now let's talk about how we can classify polynomials by degree. So the degree, if it has a degree of 0, then we say it's a constant. The degree is based off of the variables. So if there's no variable, then we call it a constant and it has a degree of 0. So an example would just be 7. Any whole number, okay, would have a degree of 0. Okay, a degree of 1, okay, means that it's linear. So think about the linear equations that we graphed, okay, based off that variable x plus 3. Okay, it has an exponent of 1. We don't see it, but there is actually an exponent of 1 on that x. Okay, so we've always talked about that x has, if we don't see it, it's automatically a 1. All right, a degree of 2. Okay, we call that a quadratic. So an example of a quadratic would be 2x squared plus 3x minus 5. So it's based off of the highest degree. 5 has a degree of 0, 3x has a degree of 1, 2x squared has a degree of 2. So since 2 is the biggest one, we're going to call that a quadratic. A degree of 3 we call cubic. So an example would be x cubed minus x squared plus 5. So again, we have that constant term with a degree of 0, the quadratic term with a degree of 2, and then the cubic term with a degree of 3. The degree of 3 is the biggest, so the whole polynomial falls under that classification of cubic. Okay. Fourth degree, we often will call quartic. Okay. And then fifth degree, we often call quintic, and can look something like that. Anything beyond that, we just name it as the 6th or 7th or 8th degree, or so on. So we only have specific names up through the 5th degree. All right, now let's take a look at some more vocabulary. So in math, we always like to write things down in a very specific way, and they try to keep things standardized so that people across different disciplines and different countries, everyone's doing everything the same. So everything's very standardized. So the standard form of a polynomial means that terms are ordered by degree. So the highest degree first, the lowest degree last, so least to greatest. Whoops. There we go. All right, let's take this out for a second. All right, so here's an example. So 4x to the 7th minus 3x to the 5th plus x to the 4th plus 5x minus 9. So first let's take a look at what the degrees are of each term. This term has a degree of 7. This term has a degree of 5. This term has a degree of 4. This term has a degree of 1. And then this is my constant term with a degree of 0. So again, it's always going to be ordered by the highest degree first, the lowest degree last. So basically, if you think exponents, greatest to least. Right? Leading coefficient. Right? The leading coefficient is that very first coefficient in the polynomial. So I'm going to put that in because that's not here. So your leading coefficient is the first coefficient of the polynomial. So an example, what did I just do? All right, so an example of that. Oh, that's what I took that out already. Forgot that was there. I just took it out. The coefficient at the front of a polynomial in standard form. There we go. All right, so here's an example. So when this is in the proper order, from my biggest exponent down to my smallest exponent, okay, my leading coefficient is 4. And so that's the only thing we would look at. All right, now let's get down to the math. All right, so we're going to take a look at a skill that we've actually already done before. We're just going to look at it in a slightly different way. So adding and subtracting polynomials. So basically all we're doing is combining like terms. They have to have the same variable and the same exponent. So that's going to be kind of the key thing that we have to look at. So here we're adding. Adding's pretty nice because we don't have to change anything. We don't have to manipulate anything. So we can look at combining those like terms. And there's a couple different ways we can do this. So the way that it's presented here is just taking a look at those like terms. So 3x squared would pair up with 4x squared. So we can put those together, and that gives us 7x squared. When we're adding like terms, we do not change the exponents. The exponents will stay the same. We only add the coefficients. All right, then we've got a 4x, which will combine together with that negative 8x. So 4x plus a negative 8x. And you know how I feel about those double signs. Remember, that's just another way of saying 4 minus 8. So 4x minus 8x will give us a negative 4x. Then we have our constant terms, the negative 3 and the negative 9. So now I can combine those together. My negative 3 plus my negative 9. And that's going to end up giving me a negative 12. Now we can take these three terms, they're all different. This is a quadratic term, a linear term, and a constant term. We can now put it all together as one polynomial. It would look like this. And based on the number of terms, we would call this a trinomial. And it's to the second degree. So this is a quadratic trinomial. So I'm just going to put that over to the side. Oops. There we go. So quadratic trinomial. Just to have a little more practice at classifying. All right. You're going to have one try on your own here, but let's go through and do the next example together first. All right, this time, when there's subtraction here, we have to be really careful. So there is actually a 1 in there, and we've worked with that before. There's actually a 1 here, a negative 1. So when we're dealing with that, we need to make sure that we distribute that negative 1 throughout. We can't just leave it as that subtraction symbol. So we have to distribute that negative 1 across everything in that second set of parentheses. So when we do this, I'm going to do the negative 1 times negative 5r cubed. I'm going to do negative 1 times positive r, and then I'm going to do negative 1 times 8. This first group, I'm just going to bring straight down. Okay? And then the second group, the second part is what I got when I distributed. So negative 1 times negative 5r cubed was positive 5r cubed. Negative 1 times positive r is negative r. Negative 1 times 8 is negative 8. All right, now we can go ahead and combine our like terms. Let's work in the proper order. So the biggest exponent in this case is the 3. So that term 5r cubed. And then we're going to look through the rest of these, and we don't have anything else with an exponent of 3, so that term's going to stay on its own. Now I'm going to look for the next biggest exponent, and we have a 2. So this term here, this quadratic term, would go next. It does not have anything else to combine with. So remember, it doesn't matter that the variables are the same, they also have to have the same exponent. All right, then we have our linear terms. So I've got a 2r and a negative r. So those two can be put together. And then we have our constant terms, a negative 1 and a negative 8. All right, so now let's see what we have. There's nothing to do with this term. There's nothing to do with this term. But this one I can combine together. So 2r minus r is going to just give me r. Negative 1 minus 8 is going to give me a negative 9. Now I have my terms all in order. 5r cubed minus 9r squared plus r minus 9. If I wanted to classify this polynomial, I would say that it is a cubic polynomial because it's 4 terms. So anything over 3 terms, it just refers to as a polynomial. So if I were to classify this, I would call this a cubic polynomial. Okay, let's go to the next page. And you'll have another try on your own. Watch out for the subtraction. Make sure you put your 1 here and distribute that -1. All right, now let's take a look at this and see if we can apply this idea. So we're going to find the perimeter. And if you remember back to middle school, maybe even before that, 5th, 6th grade, perimeter just means the distance around the outside edge. Perimeter is just the distance around the outside edge. So we're going to add them all together. The formula for perimeter for a triangle is just the side plus the side plus the side. So we're going to set that problem up. We've got 12b minus 8 plus 9b plus 8 plus 12b minus 8. So now we're going to take those 3 sides and we're going to add them together. So let's start with our b's. Okay? So in this case, our highest degree is 1. So all of our terms with a b in it are all linear. So we can add those together. I've got a 12b, a 9b, and a 12b. When I add those all together, that gives me 33b. All right, now we can look at our constant terms. The -8, the +8, and the -8. We'll add those all together, and we get -8. Now we can take those 2 terms and write it together as one polynomial, one expression, 33b minus 8. Okay. And then there's one more try on your own. Here's the perimeter formula for finding perimeter of a rectangle. All right, that concludes our notes. You have 3 try on your own problems. Please make sure those are completed before coming into class next time. I'll see you then.